Welcome to Organic Chemistry Decoded, where we are breaking down organic chemistry so you can ace that exam. Let's do some NMR practice problems today. So we're going to do carbon NMR and match it to the structure we have. So we have our carbon NMR spectra with our molecule here, and we're going to match these signals to the carbons here. So we have our spectra here, and we're already given, they're numbered for us, so that's already easy for us. Then we have our structure. So the first thing that I like to do is I like to figure out how many unique carbons are on that structure. So what we can do here, and as we look, there is an internal plane of symmetry on this molecule. So that means that these carbons are equal to these carbons. So and then if we go through it here, we have 1, 2, 3, 4. We have 4 unique carbons, which is great because we have 4 signals. So if we go through it now, let's start with our spectra. So the first one we have right here, kind of a smaller signal. And remember, carbon NMR generally isn't quantitative. How- However, the intensity of a signal can sometimes tell you some things. Generally, the way it was always taught to me is that the better the carbon signal, it has a slower relaxation time. I'm sorry, faster relaxation time, which means it's a little more floppy. So, in a carbon with a slow relaxation time is less floppy, it's more rigid, means it's usually bonded to more things. So if we look, but if we look here, that it's at roughly, let's call it 185, give or take. And so, if you remember anything, hopefully from what you learned in lecture, that is smack dab in the middle of the carbonyl region for carbon NMR. And so, do we have a carbonyl in our structure? Yes, we do, and it's right here. So, number one is our carbonyl, and then next, let's go to two here. So, in that region, it could be a couple things. You might see some aromatics, but a big one, and this is an alkene region. So, like your double bonds, that's where you're going to see a lot of that. And so, do we have a double bond? Yes, we do. We have that cyclopentene. So, we have a double bond there. So oop, this carbon right here, that's going to be number two. And so now we're left with two more carbons, both right here in this aliphatic region. And so you can't really tell them apart because remember, intensity isn't always accurate in carbon NMR. It's not quantitative generally. But what we can do is these are down, this one's downshifted. So which one is closer to a more electro withdrawing group? And that would be our alpha carbon right here, this one. And that's because this carbonyl is pulling electron density up that way. So it's pulling electron density away from that alpha carbon. I just realized I labeled that 2. This should be a 3. It's a shitty 3. Mm. Away from that alpha carbon, it's going to make it downshift. And then so that leaves this CH2 as our number 4. So that was a quick little practice for you guys. Hope that's helpful. Remember, when you're going through carbon NMR, make sure you have the right amount of signals. Then go and figure out how many unique not hydrogens, carbons you have on your the molecule that you think it is, or that it is, depending on how the problem is set up. And then go through and start looking at distinct regions in the carbon NMR spectra. So like go look at the carbonyl regions, then look if you have carbonyls, go look at the alkene region, see if you have alkenes or aromatics, look at the aromatic regions, and so on and so forth, and start working through by process of elimination. And that will clear out the really easy ones. So that way, when you're left with the harder ones, you already know what's eliminated and you can make a better educated guess as to what it is. And as always, if you have any questions, drop them below in the comments, and you can always DM them to me directly. I do answer DMs. So if there's anything that you didn't understand in lecture or a problem you got wrong in your exam, or if you have some practice problems you don't understand how to work through them, shoot them over to me. I'll help you work through them, and I'll make a video so you can get through them together.